Hello friends, welcome to Learner's Planet. Friends, in this session I am solving the doubts sent by the students on basically on number system. You must attend the basic sessions before you come for this practice session or doubt session. And once again, just try the problem on your own. When the question appears on the screen, just pause the session, try to do it on your own, and then just watch the solution and explanation. Okay, so let's take the first problem of the session. See this question. The greatest common divisor of 3 raised to 3 raised to 333 plus 1 and 3 raised to 3 raised to 334 plus 1. Okay. See here what I do is I assume 3 raised to 333 is x. Okay, so this expression will be 3 raised to x plus 1, right? This 3 raised to 333, I assume it to be x. So this is 3 raised to x plus 1. Now 3 raised to 333 into 3, that is actually 3 raised to 334, right? So 3 raised to 333 into 3, that is 3x. Okay, so this expression will be precisely 3 raised to 3x plus 1, or I can say 27, or maybe it's leave it like this. Now see, suppose it's a plus 1, right? I assume a is 3 raised to x. Then this is a cube plus 1. Then a plus 1 will always be factor of a cube plus 1, right? That means 3 raised to x plus 1 will always be factor of 3 raised to 3x plus 1, right? That means this number is factor of this. That means this is the HCF, that is the greatest common divisor. Okay? I hope you are clear. The mode of the given data. What is mode? Mode in the given sequence, or in the given this numbers. Not in fact, this is not a sequence. In these numbers, the number which is appearing for maximum number of time is mode, right? Mode is the number that appears maximum number of times. Okay, so here 70, 70, 70, it is 3 times, 68 no, 72, 1, 2, 3, 4, 4 times 72 is there, 70, 68 and 66 just 1. Okay, so 72 is the mode of this given data. If both the numerator and denominator of a proper fraction are increased by 1, it becomes 2 by 3. So what is a fraction? So that's very simple. You just can go by option also. See, first of all, both the numerator and denominator of a proper fraction. So option 1, it is not actually a proper fraction. In a proper fraction, numerator should be less than denominator. Okay, then only it is a proper fraction. Now we have 1 by 2, 1 by 4, 3 by 4. What you can do is we just add 1 in the numerator and denominator and see whether you get 2 by 3 or not, right? So if you take this 1 by 2, if we add 1 in the numerator, we'll be getting 2, and 1 in the denominator will be getting 3. So that's pretty simple. You are getting 2 by 3. So no paperwork is required at all. Just go by options, right? A number x when divided by 289 leaves 18 as the remainder. The same number when divided by 17 leaves y as the remainder, the value of y. So precisely what we have to do, we have to divide this number x by 17 and have to find out the remainder. Now see, dividend is equal to quotient into divisor plus remainder, that we have discussed in detail in our basic sessions, right? So dividend is equal to quotient into divisor plus remainder. Okay, now here dividend is x, quotient we don't know, I suppose it is maybe a, and divisor is when divided by 289, so it is 289, and plus remainder is 18. So this number x is 289a plus 18. Okay, now we have to divide x by 17 and have to find out the remainder. So when x is divided by 17, So it is 289a by 17 plus 18 by 17, right? Remainder from this plus remainder from this. So here 289a, see 289 is the square of 17, that means it is multiple of 17. So from this division you will be getting remainder as 0, right? And from this division, if 18 is divided by 17, the remainder will be 1. So overall remainder will be 1. So these sort of problems are really very easy. You just have to write the number in this format, that is 289a plus 18, that is quotient into divisor plus remainder, right? Then whatever the next number that is given to you, just see and find out the remainder from this. So you must be knowing remainder of a plus b, right? So when you have a divisor like 17 over here, so remainder in this case plus remainder in this case will be overall remainder. So whenever overall remainder is more than the divisor, then just deduct the divisor, otherwise that will be your remainder. So in this case the remainder over here is 0 and remainder over here is 1. So final remainder is 0 plus 1, that's 1. That's already less than 17, so that will be your final answer. Okay, so that's pretty simple. A rational number between 3 by 4 and 3 by 8. Now in this question you don't have to touch even your paper and pen. A very simple question from SSC CGL paper 2013. See, 3 by 4 and 3 by 8, both of them are less than 1. So if any fraction is between these two, it has to be less than 1 obviously, right? So you just say 12 by 7 more than 1, 7 by 3 more than 1, 16 by 9 more than 1. Only one option that is less than 1, that's 9 by 16. And there is none of these, so no calculation is required, right? And this is the final answer, 9 by 16. And otherwise, how would you do this? See, if in the denominator, if you see this number 16, what you can do, you just convert the denominator into 16. So for that, 3 by 4 in the denominator, if you want 16, so it can be written as 12 by 16. And this as double of that, so it is 6 by 16. Right? So now this is denominator 16, this is 6, this is 12, so 7 by 16, 8 by 16, 9 by 16, 10 by 16, 11 by 16 till 7, from 7 till 11. So these many numbers will be between 3 by 4 and 3 by 8. Okay, this is the method as the general method, but over here it's not at all required because both the fractions are less than 1, so obviously the number between them should also be less than 1. So we just have one option, that is less than 1. Okay. Similar question from the same paper, maybe from another set. 425 gives a remainder 45 and the same number is divided by 17. What will be the remainder? That means your number is 425a plus 45. We have just discussed, so I will not write down the entire story once again. Now you have to divide it by 17 and get the remainder. 425, bright chances are that this number will be multiple of 17. Just write out 17 2s are 34 and 17 5s are 85. So over here the remainder is 0. Over here 17 2s are 34. So remainder is 11. Okay, so the question can be done in 20-25 seconds. For a certain month, the dates of 3 of the Sunday are even numbers, then the 15th of that month falls on a. Okay, I assume the first Sunday date is X, then the second Sunday X plus 7, third Sunday X plus 14, fourth Sunday 21, and then 28. It makes 5 Sundays can be there. Now we want the 3 numbers to be even. See here, X plus 14, not X plus 14, but if I take X as an odd number, then this will be odd, then this will be odd, but we want it to be even, and even this will be odd. So we are left with just 2 even. So I take X as an even number. So if it is even, suppose I take X as 2, so this is 2, 9, 16, 23 and 30. Okay, so 2, 16 and 30, right? So these 3 are even dates and these are Sundays, right? That means on 16th it is Sunday, then 15th of that month falls on a Saturday, right? Pretty simple. Instead of 2, if you take 4, then that will exceed 30. So this is the only possibility we have, right? And if we take less than 2, then we are not getting 3 Sundays on even dates. There are 50 boxes and 50 persons. Person 1 first or 1 keeps 1 marble in every box. Person 2 keep 2 marble in every second box. Person 3 keeps 3 marbles in every third box. The process goes till person 50 keeps 50 marble in the 50th box. Find the total number of marbles kept in the 50th box. Okay, if we go by option, then 43 and 6 are already eliminated. Now see what is happening there. It is an interesting question. What is happening over here? Say first person is keeping 1 marble in every box. Person 2 is keeping 2 marble in every second box. So precisely person 2 is keeping 2 marble in even number of boxes, right? Person 3 is keeping marble in multiple, in the boxes having number as multiple of 3, right? So precisely in 50th box, what will happen? The person will put the marbles in this box will be having their factors, right? So first person, because he is putting the marble, keeping the marble in every box, so definitely. Second person, because he is keeping the marble in every alternate box, so he will also go to 50th box. The third one will not go to 50th box because he is putting the marble in 3, 6, 9, 12, and so 50 will not come in his case. Similarly for 4 it will not be there. So for 5, yes, 5, 10, 15 till 50th he will go. So fifth person will also keep the marbles. Then for 6, 7, 8, 9, 10th person will also keep the marble. Then 11, 12, no other one. After that the factor of 50 is 25 and then 50, right? So first person will keep 1 marble, second person will keep 2 marble, then 5, 10, 25 and 50. So in all these many marbles will be there, right? The logic is very simple. The number of the third person, the 7th person, the 9th person will not go to 50th box. Okay, they will, suppose the 3rd person is there or the 8th person is there, he'll go to boxes 8, 16, 24, right, which are multiple of 8. Okay, so in all we can see 20, it's a 75, 85, 85 and 590, 2 and 3. So this is your answer. Okay, fully logical problem. The number of odd composite divisors of 1848. See, when I'm discussing this question, what I do is I just explain you once again how to find out the total number of divisors of any given number, right? So what you have to do, first of all, 1848, you just factorize the number. Suppose you have a number, maybe any number n, and you factorize it and you get a raised to x into b raised to y into c raised to z and more maybe. So the total number of factors, see here a, b, c, these are prime numbers, right? So the total number of factors will be x plus 1 into y plus 1 into z plus 1. Total number of factors over here include 1 and number itself, right? So these are the total number of factors, or what you can say is the divisors. So here the same fund I'll apply for 1848. First of all, what I have to do, I just have to go for the prime factorization of 1848. So it is divisible by 8, so it's 8 into 8 and 8, 16 minus 5, it's multiple of 11 also. So it is 2 raised to 3 into 3 into 7 into 11, right? So it is 3 raised to 1, 7 raised to 1, 11 raised to 1. Now if the total number of factors are asked, it will be 3 plus 1, 1 plus 1, 1 plus 1, 1 plus 1, right? 3 plus 1, 1 plus 1, 1 plus 1, 1 plus 1. So 4 into 2 into 2 into 2. 4 2s are 8, 2s are 16, 2s are 32 factors will be there, inclusive of 1 and 1848, right? So that's a general idea I'm giving you. Now in this particular question you are asked about odd composite divisors. See, when we are calculating the divisors as 32, it includes this number 1 also, which is not composite. It includes 3, 7, 11, 2, all of them which are not composite, right? But we have to find out odd composite divisors. So odd composite, that means we want odd also and composite also. So we need to eliminate 2, 3, 7 and 11, right? But we even want odd also, so we need to eliminate and 2 entirely. Okay, so this complete thing will be eliminated, right? Now we are left with 3 and 7 and 11. Now combination of 3, 7 and 11, they will be also factors of this. We have already calculated this in number 32, but we have to find out how many of them will be odd and composite, right? Now 3 itself, 7 itself and 11 itself, not composite, all of them are prime number, but 3 into 7, it's an odd number and composite number. Similarly 3 into 11, odd and composite, 7 into 11, odd and composite, 3 into 7 into 11, odd and composite. So we just have 4 combinations with the numbers are odd as well as composite. Okay, so we eliminated 2, all the numbers which are multiplied by 2 cannot be odd and composite. So that's eliminated. From 3, 7 and 11 we got this 4 combinations which are odd as well as composite. Okay, so what is your answer? The number of odd composite divisors or odd composite factors is 4. Okay, so if you understand this concept that this is 2 cube into 3 into 7 into 11 and these are the total number of factors, and if any other question is asked you can do it very easily, just you have to be careful about it. So total number of factors are 32. If you are asked how many factors of 1848 are there when 1848 and 1 is eliminated, or we can say how many prime and composite factors are there. In all prime and composite, so they will be 31, right? In 32 1 is also included and 1 is neither prime nor composite. Okay, and how many factors are there which are less than 1848? So in this 32 1848 is also included, so we can say 31 factors of 1848 are there which are less than 1848. Okay, so this concept should be clear in your mind. So total number of factors, if you don't know the formula, just write it down. And the preliminary condition is that A, B, C over here, A, B, C should be prime numbers, right? You just cannot take A as 4 and B as 8 and maybe 9, or C as some maybe 22 or something like that. A, B, C strictly to be prime number, then only this formula would work, right? With a 2-digit prime number, if 18 is added, we get another prime number with digits reversed. How many such numbers are possible? See, I have already explained you this concept when reversing of the 2-digit number. Any 2-digit number, suppose it is xy, so it can be written as 10x plus y. Suppose it is 53, then it can be written as 5 into 10 plus 3. So this is the 2-digit number. When the digits are reversed like this, it will be written as 10y plus x. So difference is a 2-digit number xy. So difference is actually 9 x minus y. Okay, so if xy is any 2-digit number and this is the 2-digit number and this is the number which we have obtained by reversing the digit, the difference is always multiple of 9, right? And if you divide this difference by 9, you get the difference between the digits. See, x minus y divided this 9 will be cancelled, so you are left with x minus y, that is nothing but the difference between the digits. So I have already explained this concept so many times. Now here what we want, if 18 is added, that means in original number, suppose this is the original number, if 18 is added, in that case this, I just take the smaller number. So 35 and 53, I'm just taking a random number over here. So if 18 is added, we get this, right? So this can be possibly a combination when we add 18 to a number and the digits are reversed, right? Now, whenever the difference between the digits is 2, whenever the difference between the digits is 2, difference between the digits is 2, and if you multiply that by 9, the digits are reversed. You see, the difference between 35 and 53 is 18. When the difference between the digits is 2, the difference between the numbers and the reverse digit number is 18. Okay, which I am getting over here. 9x minus y, right? If you don't divide it by 9, what is the difference between these two numbers? That is 9 times x minus y. So if x minus y is 2, that means the difference between the digit is 2, then the difference between xy and yx will be 18. Okay, that is 9 times. You can take any other examples also. Suppose you have number 47 and 74. So difference between the digits is 3. So difference between these two is 9 into 3, 27. So that you can calculate easily. Now in this particular case, we are looking for a number which is already prime, and if we add 18, then the digits are reversed. So, and the reverse digit number is also prime. So the first thing, the difference between the two digits should be 2. Then only we'll be getting the reverse digit number when we add 18, right? So we just write down the possible combination, that is 1 3 2 4 3 5 4 7 5, I'm sorry, 3, we want 2, so it is 6 7 6 8 7 9, then that's it. Okay, so these are the two digit numbers. So when we add 18, the digits will be reversed, right? 31, 42, 53, 64, 75, 86 and 97. Now first of all, the number should be prime, so we just eliminate the non-prime numbers. Okay, now we are left with 13 and 79. Now 13, if the digits are reversed, we get 31, so that's also prime, and 79, when the digits are reversed, we get 97, that is also prime. So we just have two numbers which fulfill this condition. If 18 is added, the digits will be reversed, and the reverse digit number will also be a prime number. Okay, so it's a single question, involve too many concepts, right? But all this you must be knowing. Okay, after that you just have to do this much work. If you already know this, then you just have to do this much work, right? So the problem can be done in seconds if you know all these concepts. So here we just have two numbers, that is 13 and 97. Okay. If 1 cube plus 2 cube till 9 cube is this, then value of this. Now that's pretty simple question. See, what you can do is 0.11 cube, you can take it as common. So you're left with 1 cube plus 2 cube till 9 cube, right? You just take it as common. Now 1 cube plus 2 cube till 9 cube, you already know the answer, that is 2025, right? And then we have 0.11 whole cube. So what I do is 11 cube by 100 cube. So 11 cube is 1331. Okay. Now we just have to get the approximate idea of the answer with initial digit. It will maybe 2 or 3, and whether we have any number before decimal or not, any digit before decimal or not, right? Now in the denominator I am having 6 zeros, like that is 100 raised to 3. So what I do is, to make it simple, I do it like this, right? So 0.025, 0.331, that means definitely we are going to get a number that is more than 1. So these options A and B are eliminated. Now the next thing is whether it will be 2 point something or 3 point something. So see, this is around 2 and this is less than 1.5, right? So if 2 is multiplied by 1.5, then we get around 3, right? Exactly 3, but this is something more and this is actually less, so around 3 we get, right? But in this case it is less than 1.5, though it is bit more, but very bit more than 2, but it is very less than 1.5. So our answer cannot be 3 point something, because this is something 3.7, right? So we cannot get that. So our answer is 2.695. Okay, though we'll be having a very big number, so this is approximated answer. It's already given over here, so do not try to go by digital root technique or unit digit technique. You'll be making blunders in this case. Okay, so just get around idea what the answer will be. It's around 2.695. Okay, and if you just see, that's a 13 into 2, it's 26. So your initial digits must be 26. Okay. The sum of 5 consecutive integers is a and sum of next 5 consecutive integers is b, then b minus a by 100 is equal to. That's very simple. Just take the sum of first 5 consecutive integers, you start from 1. So 1 to 5, the sum will be 5 into 6 by 2. Right, the sum of first n natural numbers is given by n plus 1 by 2. Or what you can do is 1 2 3 4 5, just the middle number into 5. You just do middle number into 5 because this is the average value and there are 5 numbers, so it will be 15. So sum of first 5 consecutive integers is 15. Similarly, next is 1 2 3 4 5, so the next is 6 7 8 9 10, so it will be 24. So a is 15 and b is 24. I'm sorry, 40. Right, 8 into 5. So b is 40, a is 15 by 100. So 40 minus 15, 25 by 100, it's 1 by 4. Simple. If a is this, b is this, value of this. So whenever you are given this sort of expression, just try to recall the algebraic formula behind this. So here it is 5a whole square and this is 4b whole square. So seems that it is an a plus b whole square formats. Let us see the middle term. It is 2 into 5a into 4b or not. So 5 4s are 20 into 2, 40ab. So this is precisely 5a plus 4b whole square, right? 5a plus 4b whole square. So 23 into 5, 115, minus 29 into 4, the 29 into 2, 58 into 216 whole square. Okay, so that's minus 1 whole square, that's 1. Simple. Both the n digits of a 99 digit number n are 2, n is divisible by 11, then all the middle digits are. Okay, see here, this number is 2, then we have 97 digits over here and this is number 2. Okay, now what is the divisibility rule of 11? That is, suppose I have a small number, maybe a, b, c, d, then b plus d and a plus c, right? A plus d should be equal to b plus c, or we can say the mutual difference should be 0. Okay. So here the total number of digits are odd in number. So suppose I have a 5 digit number. Suppose instead of this a, b, c, d, I have a, b, c, d, e. Then what would happen? A plus c plus e should be equal to b plus d, right? So the same concept we will apply over here. This is the first digit, that is the unit digit, and this is the 97th digit. I'm sorry, 99th digits. So precisely these two will be surely added. Okay. So, and suppose the remaining digits are x, 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 we assume. So x for 97 times. So in this story, 50 number will be on the left hand side and 49 number will be on the right hand side. So it is 2 plus 2, both the 2's will be there on the left hand side, plus 48 times x, and in the right hand side there will be 49x. So in a 48 numbers, 48, 49 and 50 numbers, and here is side 49 numbers. So in all 99, digits. Okay, but the 2 and 2, both the 2's will be in on this side. So here x is equal to 4, that can be calculated very easily. I hope you are getting my point. In 99 digits, see in this 5 digits, 1, 2, 3 digits on the left hand side and 2 digits on the right hand side. So when we have 99 digits, 50 digits will be at the left hand side and 49 digits at the right hand side. Okay, and this 2 will be first digit and this 2 will be 50th digit. So first digit and 50th digit, both of them will be on the left hand side. You can even take a smaller example of this to understand it in better manner. Suppose I take 9-digit numbers. So 2x, x, 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 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right? So here 2x, x, x and 2. Right? 2 plus 1, 2, 3, 2 plus 2 plus 3x, that's on left hand side, and 1, 2, 3, 4x on the right hand side. Okay, so you get x as 4. So I hope the this concept is clear in your mind. So the answer must be 4. Okay, 2 raised to 16 minus 1 is divisible by. So that's pretty simple question. It's a raised to 16 minus b raised to 16. 1 raised to 16, it's just 1, right? Now what we can do is we can factorize it. It can be factorized as 2 raised to 8 minus 1, 2 raised to 8 plus 1. Further it can be 2 raised to 4 minus 1, 2 raised to 4 plus 1 and the same. Further it can be 2 raised to 2 minus 1, 2 raised to 2 plus 1 and so on. You don't have to write everything. You just see over here 2 raised to 4 plus 1, that's a 16 plus 1, 17. So 17 is definitely a factor. Since there is none of these and no other combination, don't move further. Okay, 17 will be your correct choice. Okay, in this case the remainder when 17 raised to 37 plus 29 raised to 37 is divided by 23, what is the remainder? Okay, precisely see a raised to n plus b raised to n has factor a plus b if n is odd, right? And it doesn't have any factor, that means, or we can say just 2 factors if n is even. Right, in here we are talking about n is odd. So a raised to n plus b raised to n will have, if n is even, then there may be various factors, but we are not so sure about a plus b, right? So but in case of a raised to n plus b raised to n, if n is odd, for sure a plus b will be a factor. Similarly, for a raised to n minus b raised to n, if n is odd, then for sure a minus b will be a factor, right? And when n is even, then a minus b and a plus b, both of them will be factor. You can take example of a square minus b square. So when n is even, so a square minus b square has both the factors a minus b and a plus b. But if you talk about a cube minus b cube, a minus b is a factor, but a plus b will not be, right? Similarly for a cube plus b cube, a plus b will be factor, but a minus b will not be. Okay, so you have to be careful about it. If you are confused at any stage, you just take the small examples like this. Okay, so in this case a raised to n plus b raised to n will have a factor a plus b if n is odd. Now here we can see n is odd, that is the power is odd. So 17 plus 29 will definitely be a factor. So 17 plus 29 is precisely 46. Right, so this number is actually 46 multiple, or I can say 46k. So if any number is multiple of 46, if it is divided by 23, the remainder will be 0. Okay, because 46 itself is multiple of 23. So very simple algebraic expressions knowledge or algebraic relationship, or you can say formula, if you know, you can solve this sort of problems very easily. Okay. Both the problems are from unit digit. Cyclicity of power we have already discussed in our basic sessions. 2 raised to 33 is divided by 10, the remainder will be. Now 2 has cyclicity of 4. So 2 raised to 1 and ends with 2, 2 raised to 2 ends in 4, 2 raised to 3 ends in 8, and 2 raised to 4 ends in 6. Okay, then 5, 6, 7, 8 and so on. Now 33, it's some 4x plus 1 format, so 33 will end in 2. Right, so unit digit of 2 raised to 33 is 2. So if unit digit is 2, then the remainder when this number is divided by 10 will obviously be 2, because whatever is the unit digit, that is the same number which is obtained by dividing that particular number by 10. Right, suppose you have 58. So if you wish to find out the remainder when 58 is divided by 8, obviously it will be 8, that is a unit digit. Okay, so precisely you have to find out the unit digit. In this case, that's 2. And you must be knowing the cyclicity of power that I've explained in detail in our basic sessions. So if you're not clear, just do attend it once again. And if, even in that session, I told you not to write this much. You just go use your fingers. Okay. Now this problem, the second one, I'll be just using my fingers to solve. Here 7 and 1. See, any number that ends in 1 or any power it will be, unit digit will be 1 only. So we just have to consider the unit digit of this. So it is 7 raised to 245. Okay. So what you have to do, it's a 245 when divided by 4, the remainder is 1. So it is 4x plus 1 format, right? So just use your fingers. 7, 7s are 49, 7s are 63, 7s are 1. Again 7. So 4x plus 1, the unit digit will be 7 only. So in this product, 7 into 1 unit digit is 7. Okay, so do not write the entire equation, entire theory. You just use your fingers in your exam to solve this sort of questions. Whenever you have to find out the unit digit, you have to use cyclicity of power, and cyclicity of power question you should be using your fingers, right? Two more questions. Which one of the following will completely divide this? Okay, so what you can do is you just take 5 raised to 71 as common. So inside the bracket you'll have 1 plus 5 plus 25, right? So 25 plus 5, 30 and 31. So 31 is definitely a factor of this expression, but we don't have 31 among options. So what we can do is 5 raised to 21. Instead of 5 raised to 21, I write 5 raised to 20 into 5. Right? So 5 into 31, we have 155. So that's there in the option. So it is definitely divisible by 155. In seconds, you can solve it. When n is divisible by 5, the remainder is 2. What is the remainder when n square is divided by 5? So we choose any number which is divided by 5 and remainder is 2. Suppose I take 7. So when 7 is divided by 5, the remainder is 2. Now, what is the remainder when n square is divided by 5? So 7 square, that's 49. If it is divided by 5, the remainder is 4. So no need to go further. So very simple example you can take. Your answer must be 4. Okay. So within seconds, you should be able to solve this sort of problems. If you wish, you can take any other example. Suppose I have number 12, right? That is, if it is divided by 5, the remainder is 2. Now just go for 12 square, that's 144, which is divided by 5, remainder will be 4. So that's same in every case, okay? And why it is happening, just listen to me carefully. See, when you divide a number by 5, the remainder is 2. That means the number is in 5x plus 2 format, right? Now, 5x plus 2 format, if it is squared, so you'll be getting 25x square plus 20x plus 4, right? So if it is divided by 5, the remainder is 4, because this number is multiple of 5, this number is multiple of 5, so obviously you'll be getting the remainder as 4 only. Okay, so that is algebraic story behind this, but in examination you can perform this sort of calculations. And when you see this big expressions like very lengthy problem, just recall the algebraic expression behind this, right? Always there is an algebraic relationship, algebraic formula behind this. Here you can see that's a square plus b square minus 2b. So that is nothing but a minus b whole square, right? So it is a minus b whole square. In the denominator we have a square minus b square. So that is a minus b into a plus b. Right? So precisely we are having a minus b upon a plus b. So a minus b, that means 3.75 minus 3.25 minus 1.75. So 3.25 minus 1.75 to 1.5 by a plus b, that is 3.25 plus 1.75, 3, 4, and this is 5. Right? So 5 3s are 5 10, so that's 0.3. Pretty simple. Here you can say a cube plus b cube. So this is already very easy. It's a 0.9 cube, that is 9 cube is 729. So here we'll be having 0.729, and this is a 0.001, right? So it's very simple, 0.729 and 0.001. So we'll have 0.73. Okay. I hope you are clear. the remainder when 3 raised to 21 is divided by 5. See, in case of 5 and 10, what you do is you just find out the unit digit of the expression, right? Whatever is the unit digit, according to that you can find out the remainder in case of 5 and 10. Now 3 raised to 21, again 3 carries the cyclicity of 4. So 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4. Just do it on your fingers. It will end in 3, 9, then 9 3s are 27, 7 3s are 21. Again, for 3 raised to 21 will come over here. So 1, 2, 3, 4, 5, 6, 7, 8. So the unit digit of 3 raised to 21 is 3. Right? So if any number is having unit digit as 3, maybe any number. If it is divided by 5, the remainder is 3 only. So whatever is the unit digit, according to that we can decide what is the remainder. If the remainder digit is, unit digit is 7, suppose in this case, then just divide 7 by 5 to get the remainder. Okay, so that's pretty simple. So by divided by 5, if you divide it by 5, the remainder will be 3. In this case, if you divide it by 10, still the remainder will be 3. Okay, now the last digit of this expression, 1 raised to any number that will end in 1 only. So it's 1 and plus unit digit of this expression, that is 2. So overall unit digit is 3. A 30-second problem, or not even 30 seconds. You just see and write the answer, mark the answer, what I mean is. Okay. Now these sort of very simple questions are also asked in exam. See, SSC CGL 2010 paper. Now students, they just see the question and just leave it because it's looks that it involves high calculation, heavy calculations, but it's not there. It's not like this. See here, 100 minus 1 till you are going to 100 minus 200. So in the somewhere in between 100 minus 100 will also be there, right? So that's 0, so the entire calculation will be 0. So whatever big calculation is this, if it is multiplied by 0, the entire calculation will be 0, right? So you just see how simple it is. You can just solve it in 10 to 15 seconds. If you just come to know about it, this 100 minus 100 will be a term in this multiplication, right? Now this question, superb easy question, can be done in seconds. Greatest fraction, 2 by 3, 5 by 6, 7 by 8. All of them are proper fractions, and the difference between the numerator and denominator is 1, right? So when the difference, in case of proper fraction, if the difference between numerator and denominator is 1, so the fraction which is having the highest numerator will be highest, right? So among 2 by 3, 5 by 6, 7 by 8, 7 by 8 is highest. Now our comparison is between 7 by 8 and 11 by 15. Right? Now if you are confused, what you do is just go for the cross multiplication. It is 15 into 7, that's 105, and it is 8 into 11, 88. So it's 105, it's 88, so this number is bigger, right? Pretty simple. Okay, A is equal to 7, B is equal to 5, C is equal to 3, then what is the value of this? Okay, what I do is, instead of making entire calculation, I just calculate the unit digit. So that's 2, 0 or 8. Let's see what happens. 7 sevens are 49 plus 5 plus 9 minus AB, that is 5, BC 5, CA, that's once again 5, right? So it's 10 minus 18 minus 10, unit digit must be 8. Okay, so that's in this option. So no need to go further. No need to go for the entire calculation. I hope you are clear. Now that's a very interesting question with us. In a test, 1 mark is awarded for each correct answer and 1 mark is deducted for each wrong answer. If a boy answers all 20 items of the test and get 8 marks, the number of questions answered correct by him was. Okay, so this is I'll be solving this problem using allegation method. Now what I'll be doing, I assume he has done all the 20 questions incorrect. So if he has done all the 20 questions incorrect, his marks must be minus 20. And on the other side, I'll just assume he has done all the 20 questions as correct. So his marks are 20, right? And he has attempted all the questions, so no problem at all. There is no skipping issues or 0 marking. Now actually he has got 8 marks. Right, so that will be somewhere in between. Okay, now 20 minus 8 is 12, and 8 minus minus 20, that is 28. In case of alligation, you have to be very clear that one number is bigger than this number and one number is smaller than this number, right? So this should be subtracted from the bigger number, and the smaller number should be subtracted from it. So if we subtract minus 20 from 8, so it will be written as 8 minus minus 20. That is the only thing you have to be careful about it, right? So it's 28. So it's a 4 3s and 4 7s, right? So 3 is to 7, that means 6 and 14. So 6 questions he has done incorrect, because that was incorrect and that's correct. So 6 questions incorrect and 14 questions correctly he has done. So we can make use of alligation method in solving this sort of problems. Even you wish, you can verify it also. 14. He has done 14 questions correct, he must have got 14 marks, and he has done 6 questions incorrect, that means 6 must be deducted. So he is getting 8 marks. And if this method is not clicked, what else you can do is, you just can go by elimination option, right? Suppose 16 is correct, so 16 positive and 4 negative, so that gives you 12, so that's incorrect. 14 we have already checked. 12, so 12, that means 8 are incorrect, that means minus 8 if you do, you get 4, so that's not there. So even this way you can go. So if the problem is complicated, you can, or if none of these is there, you can use alligation method. If there is none of this and simple data are there, you can even use the backward approach, that is you can check by options. So that will be also very easy, as I have explained you over here, right? So in case of 14 we have already checked. 16 is not favorable, 12 is not favorable, no need to check for 8, because it's already getting 8 marks. So that's, it cannot be the correct answer. Now which of the following fractions is the smallest? See here, we have 8 by 15, 14 by 13, 7 and 11. Just see this, both of them are having 13 as the denominator, right? So obviously 11 by 13 is not the correct answer, because it's greater than 7 by 13. Now just compare between 7 by 13 and 14 by 33. See here, if you double 7 by 13, what you'll be getting? 14 by 26, and this is 14 by 33, right? So if the numerator is same in a case of proper fraction and denominator is different, then the number which is having higher denominator will be lower fraction. So 7 by 13, if it is not even the correct answer. Now we are left with 8 by 15 and 14 by 33. If you just double it, what you'll be getting? 16 by 30. 8 by 15, if it is double, it will be 16 by 30, and this is 14 by 33. So even numerator of this fraction is smaller and denominator is higher than this. So obviously 14 by 33 is less than 8 by 15. Okay, so 14 by 33 precisely is the smallest one. So you just can eliminate the options. Okay. Okay, on the similar lines, we have this P, Q, R, S. We have to arrange them in precisely ascending order. Okay, now I have 5 by 8 and 13 by 16. So if I double it, it will be 10 by 16 and this is 13 by 16. So R is not the smallest. So just eliminate the option which is having R as smallest. So that we don't have, we have either P is smallest or S is smallest. Now I tell you one more method of finding out. I just wish to eliminate two options. So P and S I compare. Here the difference is 13 and here the difference is 3. Now the next step, multiply this difference to this number and multiply this difference to this number. So here 13 into 5 65 and here 3 into 16 48, right? So this 5 by 8 is bigger. 5 by 8 is bigger, that means P is bigger than S, right? So we eliminate these two options where S is biggest or P is smallest. So these two are wrong. In the remaining two options, S is smallest. So we don't have to now consider S. S is smallest. Now we consider P and Q and just see what happens. So here P and Q, P is 5 by 8 and Q is 7 by 12. So just you can go for the cross multiplication because that's very easy in this case. So 12 5s are 16 and 8 7s are 56, right? So P is greater than Q. So we have P is greater than Q in this option, right? P is greater than Q. So this is our correct choice. These two we have already eliminated. Out of these two, P is greater than Q. So no need to work for further. This is clear, right? So whenever you see the questions based on ascending and descending order of fractions, just do attempt them because it will hardly take 30 seconds of yours and you will definitely mark the correct answers, right? And this approach you must be knowing. If you are not able to go for the cross multiplication, if it is difficult for you or you are not able to crack it very easily, right? So you can check the difference. Here the difference is 3, here the difference is 13. So this difference into this numerator, this difference into this numerator. That will also give you the same answer. Okay.